Now see the next part, part 5 of electrochemistry. Electrochemistry. Question number 12. A standard electrode potential for SN4 plus to SN2 plus couple is, so that value is given 0.15 volt, and that for the chromium is given E naught of chromium 3 plus 2 chromium is equal to minus 0.74 volt. These two couples in the standard states are connected to make a cell. So by using this, we are making a cell. The cell potential will be, so you have to calculate the potential of this combination. So we know how to calculate a standard cell potential. So E naught of cathode minus E naught of anode, right? So how you know that this is cathode, this is anode? So cathode means reduction, where reduction happens. Anode means where oxidation happens. So reduction means gain of electron. So you can see here SN4 is gaining electron. So this is your reduction part. And obviously this will be the oxidation. So put here reduction value is 0.15 minus of minus 0.74. So this value is 0.15 plus of 0.74. So this is equal to 0.89 volt. So this will be the standard value. Write it down. Asked in 2011. Now look at the 13th question number, asked in 2010. For the reduction of silver ions with copper metal, standard cell potential are found to be. For the reduction of silver ion, so this is silver ion reduction means gain of electron doing and forming silver, right, with copper metal, and it is combining with copper. So what will do copper? Copper will lose the electron. So this is nothing. So this will lose one electron and one electron will be lost. So combination of this cell potential is 0.46 volt. The value of a standard Gibbs free energy. So you have to calculate delta G naught of this cell potential. F value we know, that is 96,500 coulomb per mole. So see how to calculate. So for copper, last electron is 2. So I will lose here 2 electrons. Right. So you can add, for solving, multiply first equation by 2 to cancel the 2 electron. So this is cancelled with this. So it will become 2Ag plus Cu produce Cu2 plus 2Ag. This is the net cell potential. So delta G naught value we know, that is minus NF E naught of cell is equal to minus 2. Transfer of electron is 2 here. So it will be N equal to 2 here. 2. F value is 96,500. Cell potential is 0.46. So delta G naught value, how much it is coming out? It is minus of 88,780 joule. Convert into suppose kilojoule. So put divide by 1000 and multiply by 1000. Then it will be minus 88.780 kilojoule. Very simple. So for solving this relation between E naught F and N is equal to minus delta G naught. So this is your standard Gibbs free energy. a standard Gibbs free energy. Now look at the next point, question number 14. So given reaction is Cu2 plus gaining 2 electron to form Cu. E naught of this reaction is 0.337 volt. Second equation, Cu2 plus gaining 1 electron to produce Cu plus. E naught of this cell is given 0.153 volt. Right. So you have to calculate for this E naught of this reaction. Cu plus 1 electron gaining producing Cu. Asked in 2009. So E naught of this reaction you have to find it. So how will you do? So first reaction is this one, this is second. By using these two value, you have to find third one. So for first, delta G naught will be minus NF E naught. Right. So we know the value of N. Here 2 electrons are gaining, right? So it will be minus of 2 into F into 0.337 volt. So for copper plus, suppose I am taking Cu plus and it is losing 1 electron. So delta G naught for this reaction will be minus of 1 into F into. So it will be 0.153. For second equation I have written this one. This is for first. Right. By adding 1 and 2, what we get? Add these two reactions now. This is your 1, this is your 2. So adding these two reactions, what we get? Bata. This Cu2 plus get cancelled, this one. Right. So you get Cu plus 1 electron to produce Cu. This is remaining, right? And 2 electron minus 1 electron. So 1 electron will be remaining. So now add these two value, this value and this value. So how much it is? Delta G naught is equal to minus 2F into 0.337. Next one is minus 1 into F into 0.153. So calculate it. What will be the value? So delta G naught is equal to 7 to the 14, 6, 7, 6. So it will be 0.674 F minus of 0.153. Add these two, so you will get here 7 to 8.0. Right. Now here look, we have reversed this reaction, so E naught will be reversed now. In second case, this reaction we have reversed, right? For writing this reaction, so it will be become minus. So this will become minus. So minus minus plus. So it will become plus now. So this is your minus part and this is your plus part. So you have to just subtract it. So say 4 minus 3 will be 1. So it will be 1. 7 minus 5 is 2. So now 6 minus 1 is 5. So answer will be minus of 0.521. Right. So now look at the next step. So delta G naught value have got minus 0.521. Right. So delta G naught is equal to minus NF E naught. N of F value is there, right? So this F and F get cancelled. Minus minus get cancelled. So and N value is 1. So E naught is equal to 0.521 volt. So this will be the answer. Now look at the 15th number. The standard free energy of formation at 298 Kelvin are given for water. So standard enthalpy of formation of water is given. That is equal to minus 237.2. Now for CO2, standard enthalpy of formation of CO2 is given. That is equal to minus 394.4. Standard enthalpy of formation for pentane is given. How much it is? Minus 8.2. The value of E naught of cell for the pentane oxygen fuel cell. So you have to calculate E naught of cell of name is pentane oxygen fuel cell. This question is asked in 2008 AIPMT. So we know the standard formation, right? So pentane when react with water it forms. So pentane formula is C5H12 10H2O. So I am writing the balancing equation. It produces 5CO2 plus 32H plus 32 electrons are coming out. And for oxygen it will be 8O2 plus 32H plus 32 E minus producing 16H2O. So add these two values. So this is get cancelled and this is also getting cancelled. So this is 10 electron, subtract here, so you will get 6 hydrogen. So adding 1 and 2, suppose this is 1, this is 2. So you will get C5H12 plus 8O2 producing 5CO2 plus 6H2O. So you have to calculate E naught of this reaction. Right. To calculate the standard enthalpy of reaction is equal to enthalpy of, so I will write here summation of enthalpy or delta G naught of product minus sum of the standard enthalpy of reactant. So it will be equal to how much? 5 into delta G naught of CO2 plus 6 delta G naught of water, right, minus. So because this is your product now and this is your reactant, so minus of enthalpy of a standard is C5H12 minus standard enthalpy of O2. So put the value now. For CO2 we know that this is for CO2. For H2O we know this is H2O value. For pentane we know, right? And for what? A standard enthalpy of oxygen, it is 0. So this value will be 0. So in the second step I will put the value. Delta G naught of reaction is equal to, so it will be 5 into minus 394.4 plus 6 into minus 237.2 minus 82.2 plus 0. So value how much it is equal to? Minus 3387 kilojoule per mole. And we know delta G naught is equal to minus NF E naught. Minus 3387 kilo means 10 raised to 3 minus 32 into 96,500 into E naught of cell. So E naught of cell will be equal to minus 3387 into 10 raised to 3 divided by minus 32 into 96,500. It will be 1.09868. This will be the value. Now look at the 16th sum. On the basis of the following E naught value, strongest oxidizing agent is. So it is given Fe CN6 4 minus producing Fe CN 6 3 minus plus 1 electron is coming out. So E naught of this reaction is given minus 0.35 volt. Next reaction is Fe2 plus losing 1 electron to form Fe3 plus 1 electron. E naught of this reaction will be minus 0.77 volt. Right. The strongest oxidizing agent you have to tell. Asked in 2008. Substances which have higher reduction potential are a strong oxidizing agent. So reduction value C, whose value is more. So negative value observe. So you can see second reaction E naught value is more now. So this is the reduction potential of the iron. So this will be the strong oxidizing agent. Right. So value is, so E naught value is more. So it is strong oxidizing agent. So answer will be Fe3 plus. Next is efficiency of fuel cell. Efficiency of fuel cell is given by asked in 2007. So efficiency represented by phi. So it will be given by delta G upon delta H into 1000. So generally fuel cells are expected to have an efficiency of 100%. So this is the formula through which you can calculate the efficiency. Delta H means enthalpy. And delta G means standard Gibbs free energy. Standard Gibbs free energy. So remember the formula. Now look at the 18th sum. Equilibrium constant for the reaction is given like Cu plus 2Ag plus producing Cu2 plus 2Ag. So E naught of this reaction is given 0.46 volt at 298 Kelvin temperature. Asked in 2007. So we know the formula. So it is RT ln of K equal to NF E naught. So it is nothing but, so it is derived from this equation. Delta G naught equal to minus NF E naught, or it is also equal to minus RT ln of K. Right? So this minus and minus get cancelled. So this is the remaining part. We have to find the equilibrium constant. So ln of K will be equal to NF E naught divided by RT. Now put the value. So N is 1, F is 96,500. E naught value that is 0.46. RT by NF. So see here. This value, when we calculate, this all are constant value. So no need to write this value. So here losing 2 electrons and gaining 2 electrons. So here it will be 2. So by solving this one, we are getting this value from Nernst equation we know 0.06, right? By N. So here I will write here 0.06 for this F by RT. So ln of K will be equal to 2 into 0.46 divided by 0.06. So calculate this one 0.03 for this. So you will get directly K equal to 4 into 10 raised to 15. So this will be the equilibrium constant.